All right, so we just needed to find where sine equals 1 over a square root of 2. So the first thing you had to do is multiply it by square root of 2 over 2. Because 1 over square root of 2 is not on our unit circle. Well, it is. It's just you might not notice it until you multiply it by square root of 2 over 2 on both sides. So you multiply it by square root of 2 over 2. Which equals square root of 2 over 2. So I'm looking for where sine equals square root of 2 over 2. And if you look at your unit circle, you'll realize it happens at 45 degrees. And it happens at 135 degrees. So you're just going to put x such that x equals 45 degrees plus 360 times k. Or it could be 135 plus 360 degrees times k. All right, but it looked like everyone got that right. So awesome. Homework questions? Fritz. Oh, the wrong one. That's why. 29? All right, so 29 was one that you had to take out your calculator for because they give you tangent alpha equals 5.42. So to solve for alpha, if it's not on our unit circle, we actually have to put it in the equation alpha equals tan inverse of 5.42, which comes out to about 79.5 degrees. Well, that's positive. And you just got to think about where tangent is positive. Tangent is positive in quadrant 1. So we know somewhere around here, that might be not enough, but here is 79.5. I don't know exactly where it is, but it's somewhere about there. And I know it's positive. These always exist in pairs. If there's a positive one that's 79.5, there's another positive one out there. You just got to remember which quadrant is positive as well. Well, it's all students take. So quadrant 3 also has a positive one right here. And the odd thing about tangents are these pairs always come exactly 180 degrees away from each other. That is just one of the properties of tangent for these. So you just have to say, well, it occurs whenever alpha equals 79.5 or when I add 180 to it, or add another 180 to it, or add another 180 to it. So our final answer is going to look something like this. It will be alpha such that alpha equals that 79.5 that I found from my calculator plus 180 degrees times k. So you don't have to do the 360. Other questions? Yeah, Brody.
Well, just for 27.
Mm-hmm.
Why do you, like, for the 194.11, how can you add there? Like, how do you know you're supposed to add instead of subtract the 14.1? Do you know what I'm saying?
Yeah, from the 360?
Well, no, I know why you did, like, that one, but then for the 194.11,
Mm-hmm.
like, how do you know that you're supposed to add for that one?
Like add 360 to it?
Add 14.1 to it. Like, how did you find that, I guess?
Oh, okay. All right. All right. So let's just work through that problem.
Mm-hmm.
So we have sine alpha equals negative 0.244, which you would have plugged in your calculator, right? And gotten alpha is going to equal sine inverse of negative 0.244, which comes out to about negative 14.1. All right, so if I look at my unit circle, and I kind of put that on there, we'll talk about it this way. All right, negative 14.11 degrees would be about here, because that's the negative direction. All right, the other way you could have done it, and what I did is I found a coterminal angle, because I know that point is about there. So I added 360 to that, which equaled 345.9 degrees. But those are both the exact same thing. They're just coterminal. All right? I'm just trying to figure out where that point is, and that point is right here. Well, if we look at a unit circle really quick, let's see if I pairs of our sines. So we're looking somewhere down here, right? We said that angle that we're looking for is somewhere about here, somewhere about there. All right, let's look at one that's close to it that we do know. Well, if sine is -1/2, it's at 11 pi over 6. Now let's find its other negative pair, which is over here, which is 7 pi over 6. So the pairs of sines, and this works for all of them, is if I come down one tick mark from there to get there, its pair must be right here. All right, it's going to match right over here. And so if we look at the angle that I created right here, that angle was at -14.2 degrees when we're down here. Well, its pair must be right here.
Okay.
And the only way to find right here is to go 180 plus whatever angle I kind of subtracted over here. All right, so if this is minus, what did I say it was, 14.1 degrees, then this one must be 180 plus that 14.1 degrees. So that's why on that homework I had to add that to the 180. And let me take a picture real quick of that final work that I did. So that's why I kind of said we had to add that 14, because I want to get that same angle as we had here. Does that make a little more sense? All right, good. Because those are tough to kind of figure out since they're not in the unit circle, and how to figure out where those pairs are. All right, other questions? Yeah, Brian. Number 3 is sine of x equals 0. Where does sine of x equal 0 on our unit circle? Well, sine of x equals 0 right there. But it also equals 0 at 180 degrees. All right? So this is the rare case that you can just put one equation down. You can put sine of x equals 0 at 0 degrees plus 180. 180k, which will just come down to just 180k or pi k. That's why my answer is just pi k or 180k. I forgot what I put as the answer. Okay, yeah, pi k or k pi. Make sense? Awesome. Other questions? All right. Today we're just going to expand upon what we did yesterday. This time we're going to solve more complex functions. So no longer will it just be sine of x equals a number. We're actually going to have an equation set up for us where it looks like sine of x minus square root of 2 equals negative sine x. In order to do these, we need to get all of our trig functions on one side and anything that's just a number on the other side. In other words, you're kind of picturing this as just being like, pretend it's just x minus square root of 2 and negative x. And how you'd solve that. Well, you get all your x's on one side, and you get all your numbers on the other side, and you go from there. So in this case, I need to get that sine x and that negative sine x on the same side. So the first thing I'm going to do is I'm going to add sine x to both sides. Let's just do that. That way I don't have a negative sine x. Well, that's going to give me sine x plus sine x is 2 sine x minus square root of 2. equals 0. Next thing I have to do is I need to add square root of 2 to both sides. So we'll have 2 sine x equals square root of 2. And finally, I divide both sides by 2 and come up with sine x equals square root of 2 over 2. Now, yesterday we talked about finding all solutions. If I had to find all solutions, we'd have that formula where I have x such that x equals some degree plus 360, or this plus 360. Look at the directions, though. It says just find all the solutions that are between 0 and 2 pi. There's only 2 places that sine of x equals square root of 2 over 2 between 0 and 2 pi, because that's just looking at my unit circle. What 2 values, or what 2 angles, is sine equal to square root of 2 over 2? And can someone tell me what 2 angles those are? Rena?
It's 45 and 135.
Yeah, 45 degrees and 135 degrees. We don't have to put an equation because it specifically said between 0 and 2 pi where those equal. So we're going to put something like you can either just put that or you can put x equals that. I'm not too concerned. And just for the sake of, just in case I ask for, if I'm doing radians or degrees, just remember that that is pi over 4. And this is 3 pi over 4. Which one would probably be a better answer based upon how the question is posed? I didn't specify which one you had to do, but there is one that I geared you towards. Brody?
The pi.
Probably the pi one, because I did say it was on the interval 0 to 2 pi. So more often than not, if I set it up as radians, I probably want the answer in radians. But if I don't specify, you can do degrees, but just lean towards what I give you, the answer. All right, our next one is 3 tangent squared x minus 1 equals 0. Well, picture this as just being 3x squared minus 1. You would add 1 to both sides, you divide by 2, and then you would take the square root. You are going to do the exact same thing. So the first thing you're going to do is you're going to add 1 to both sides. So you're going to have 3 tangent squared x equals 1. We'll divide both sides by 3 to give me tangent squared x equals 1 over 3. And finally, you will take the square root of both sides, which will give me the tangent x equals, now when you take the square root of both sides, it has to be plus or minus. I'm taking the square root of both sides, you have to have a plus or minus. And that will be plus or minus square root of 1 over 3. Well, that's not simplified because we have a square root of 3 in our denominator. So you need to multiply the top and bottom by square root of 3. And you're going to be looking for where is tangent x equal to plus or minus square root of 3 over 3. Well, since it has plus or minus, that means I'm in every single quadrant. I'm looking for quadrant 1. I'm looking for quadrant 2. I'm looking for quadrant 3. I'm looking for quadrant 4. Who could give me one of these values? Yeah, Brian.
210 degrees.
210 degrees. Can you give it in radians? Can you do the first one, though, in quadrant 1?
Pi over 6.
Pi over 6. Awesome. Pi over 6. Who can give me the quadrant 2 one in radians? Rena? 7 pi over 6. I think that's quadrant 3. How about the quadrant 2 one? Yeah, Chris. 5 pi over 6. And Fritz, do you want to give me that last one?
11 pi over 6.
11 pi over 6. Here's a nice little shortcut. If you know it's pi over 6 and it exists in every single quadrant, you know every one of them is going to be over 6. Second quadrant must be 1 less than our denominator. Third quadrant must be 1 more. The only hard part is your fourth quadrant because that was kind of the odd duck. All right, so those are our final answers. It says 0 to 2 pi, so I don't need an equation. I don't need x such that x equals something plus 360. We are done. We move on from there. These don't take a ton of thought if you know what we did yesterday. Just know what the question's asking is the hard part about these. All right, they start to step up though. This one and the next one are generally hard questions if I put it on a test. Because we have cotangent and we have cosine squared x. This isn't an identity. Note it says solve cotangent x cosine squared x equals cotangent x. Find the exact solutions in interval. So this is not an identity. We don't have to divide in half and show that the two things are equal to each other. They are not equal to each other. They're only equal to each other for specific x values. So make sure you read the questions carefully. If I'm looking for an exact answer, we're doing what we did up here. We're getting all of our trig things on one side. Maybe I should pick that one. Everything that has to do with trig on one side and numbers on the other side. I do want to preface this. You cannot divide both sides by cotangent. You cannot divide both sides by cotangent because you eliminate possible answers. It's not that it's a math error, it's just that you're eliminating answers that you could actually get. So we're not going to divide both sides by cotangent. Instead, I'm going to subtract that cotangent that's on the right side so I can move it to the left-hand side. Once again, I'm collecting all of the things that are trig on one side and anything that's a number on the other side. So we are going to turn this into cotangent x cosine squared x minus cotangent x equals 0. As it sits, this is not solvable. This is why we do this so many times. If you ever notice that in every one of those little terms you have cotangent x, you need to factor it out. Is the only way to solve this, is to factor this. If you have two things, like x squareds and x's or x's and y's, you always have to factor something out to solve it. So we're going to factor out a cotangent x, which is going to leave me with cosine squared x minus 1 equals 0. This is now the zero product property. The zero product property is if you have a chain of multiplications that equals 0. So we have a chain of multiplications that got cotangent x times this quantity. Either this equals 0 or this equals 0. So we're going to split it into those two possibilities. Either cotangent x equals 0. Two ways to get those values. Wherever tangent is undefined, cotangent equals 0. Wherever tangent's undefined, cotangent equals 0. The other way you can do it is you can look at cotangent as really just cosine x over sine x. You're looking for where is cosine equal to 0. So either I'm looking for where tangent's undefined, if you know your tangent values, or you're just looking for where is cosine equal to 0. And who can give me those two values? Right?
Pi over 2 and 3 pi over 2.
Yeah. So this one's going to result in x equals pi over 2 and 3 pi over 2. Those are two of our answers. We're not done yet because we have to solve the other one. Or we have cosine squared x minus 1 equals 0. Well, we just solve it the same way. Add 1 to both sides. We'll have cosine squared x equals a positive 1 Take the square root of both sides, and you'll have cosine x equals positive or negative square root of 1, which is really just positive or negative 1. Where is cosine equal to 1 or negative 1? Daniel?
0 and pi.
0 and pi. Yep. And you can either push these two together, or if you have them both boxed, I know all 4 of them are your answers. All right? Don't spend a whole bunch of time writing things. Just circle what do you think is the answer. Once again, if I'm asking for exact solutions, not an identity problem, it is collect all of your trig stuff on one side, all your numbers on the other side, factor if you need to. All right, our next one is another one that's very often missed on a test. And here's why it's missed on a test. Everyone looks at that one and goes, oh, it's a triple angle. I'm going to turn that into a double angle. I'm going to go tangent of 2x plus x, and I'm going to spread it apart over this giant thing. That is not what this is asking you to do. That is not what this is asking you to do. You can do that. Makes a really hard problem, and oftentimes it's not solvable. What I want you to do when you look at this problem, when you look at a problem that is a double angle or a triple angle that you're actually supposed to find all the solutions for, what I want you to do is pick a new term. So I'm going to let alpha equal 3x. And I'm going to look at this as being tangent of alpha equals negative square root of 3. Well, if I'm looking for tangent alpha equals negative square root of 3, if I look at my unit circle, tangent is negative in this quadrant, and it's negative in that quadrant. So we're just looking at those two quadrants for where tangent equals a negative square root of 3. Degrees or radians? Doesn't matter. Let's just use degrees. So you should find that at 120 degrees. And then we should also find that at, 200 degrees? Now with tangent, the cool thing is it's always by 180. So that's plus 180. That would be plus 180. So if I was solving for alpha, we would have alpha equals 120 plus 360. Okay. But we're not looking for just plain alpha. 3x is taking alpha's place. So you're going to take that 3x, and you're actually going to plug it in for that alpha. So you're going to have 3x equals 120 plus 360. I should have k's on the end of these. To solve for x, you just have to divide everything by 3. So we're going to divide both sides by 3. So I'll divide that by 3, this by 3, and this by 3. And so we're going to have x equals 40 degrees plus 120 degrees. Okay. And I also, since we're looking for all solutions, we put it in set builder notation. So I'll have x such that x equals 40. Plus 120k. Here's a really smart thing to do. Check your answer. Check your answer. Because you can reverse engineer what's happening here. If I plug 40 in here, 3 times 40 is 120. 120 is where it equals negative square root of 3. That's all I'm asking you to do. I'm asking you to find where is tangent equal to square root of 3, and then divide by 3, because it's 3 times whatever number you need to have. 3 times 40 works. All right. Questions on that? Yeah.
Why did we do 360 degrees K, not 180?
Oh, it should be 180. You are 100% right. Yep. You are 1,020% correct. Not 60 there. That should be 180 to 180 degrees. I said it. I just wrote it as 360, which should be 60 degrees K. Because tangent always should have 180. Other questions? All right, then the rest of the time is for you to work and hopefully finish your homework. Not finish it, but get close.